Alright, Algebra 2. We are on day 7 material. I need you to follow along with me on the warm-up and the new lesson. And when I get back, we'll go ahead and answer any questions that you might have had on last night's homework. So let's take a look at number 1. 4 to the 3 halves. This fractional exponent, what do we do with these fractions? We take the bottom unit and make it the root. So this is the square root, or the regular old root, of 4 to the third power. The square root of 4 is 2, raised to the third power. 2 to the third is 8. On number 2, we have a negative power. The very first thing I want you to do is put this on the bottom of a fraction. So let's make this 1 over 27 to the positive 2/3. At this point, we'll go ahead and convert our fractional exponent. The 3 is on the bottom, just like tree roots. So we're taking the third root of 27 and raising it to the 2 power. Don't forget, there's still a 1 on top of this fraction because of that negative exponent originally. Let's go ahead and evaluate the bottom of this. The cube root of 27 is 3. We're going to take that 3 to the second power. So our final answer is 1 over 9. Most folks, if they're getting this one wrong, they're forgetting that all of this work that they were doing with the 27 was on the bottom of a fraction. So make sure you give me 1 over 9 as your final answer. Alright, number 3, the first thing we want to do is distribute that negative exponent. So we're going to give that negative 2 power to everything on the inside of the parentheses. Everything on the inside of the parentheses, including the 2 and the 3. So 2 to the negative 2 power. X to the what power? The third power raised to the negative 2 power, we multiply. Power of a power, we multiply. So negative 6 power. Again with the y, power of a power, we multiply. Negative 1 times negative 2 is positive 2. Keep distributing your power. 3 to the negative 2, x to the negative 2, power of a power we multiply, y to the negative 4. Let's fix these constants. Really am bothered by the fact that they have negative exponents right now. So let's fix this 2 to the negative 2 by putting him on the bottom of the fraction and making him 2 to the positive 2. Let's do the same with this 3 to the negative 2. Let's make him 3 to the positive 2 on the top of the fraction. Now, x to the negative 6 divided by x to the negative 2. When you divide, you're taking those powers and subtracting. So what's negative 6 minus negative 2? Well, that's negative 6 plus 2. So your new power on your x is x to the negative 4. Be very careful with those. You subtract the bottom. Always subtract the bottom. Negative 6 minus a negative 2. Very similar operation with the y's. You currently have a 2 power on top and a negative 4 on the bottom. So you're looking at a 2 minus negative 4 situation, which is 2 plus 4. So your power on your y is now y to the positive 6. Last little cleanup step. Let's evaluate these constants. 3 squared is 9. 2 squared is 4. We never leave our final answer with negative exponents. So move this x to the bottom and make it x to the 4th. And y to the 6th, you can stay on top. You're a positive exponent. All right, let's look at 4. Number 4 is a FOIL problem. First times first, outer times outer, inner times inner, last times last. First times first is 15, just 5 times 3. Outer times outer, outer times outer. The things on the outside of the radical are multiplied together. The things on the inside of the radical are multiplied together. So 5 times 2 is a positive 10. And then there's no radical in the first term, but there is in the second term, so you simply have square root of 3. Inner times inner, negative square root of 3 times 3. Think of this as a negative 1 on the outside here. So negative 1 times 3 gives me a negative 3. And then square root of 3 is the only radical, so I bring it down. Last times last, negative square root of 3 times positive 2 square root of 3. Let's take what's on the outside first. Negative 1 times 2 is negative 2. Square root of 3 times square root of 3 is square root of 9. We need to combine some like terms. Let's bring this 15 down for right now. 10 of the square roots of 3 minus 3 of the square roots of 3 equals 7 square roots of 3. We want to look at the square root of 9 now as 3, because the square root of 9 is 3. So 3 times a negative 2 gives you a negative 6. I do want to do this 15 minus 6 as the last like terms to combine. So 15 minus 6 is 9, plus 7 square roots of 3. If you put this in a different order, 7 square root of 3 plus 9, that's completely fine. Number 5 definitely lends itself to some mistakes. The biggest mistake being everyone wants to just simply distribute the square to everyone on the inside, because we've been doing it for so long in our other lessons. While that's certainly something you would do if you had AB squared, you would definitely quote-unquote distribute that 2 power. You would give A the 2 power and B the 2 power. That's a situation where you have things inside here being multiplied together. You do not have that situation here. You have things added together here. So you have a different approach. You need to rewrite this as 4 square root of 2 plus square root of 3 times itself again. Once you get to this step, you're pretty much on the home stretch. Remembering to split this in 2 and multiplying itself by itself is the big key. Now it's a matter of foiling. First times first, outer times outer, inner times inner, and last times last. First times first, the things on the outside get multiplied together to be 16. The things on the inside of the radical get multiplied to be 4. Next set of terms. 4 square root of 2 times square root of 3. The things on the outside get multiplied, so it's simply 4 times 1. The things on the inside of the radical get multiplied together, 2 times 3. Now the inner terms, inner times inner. Things on the outside of the radicals, 4 times basically 1, 4. And now the inside of the radical, 3 times 2, 6. Last times last. There's nothing on the outside except essentially a 1, so we're simply going to leave it alone. So inside the radical we have a 3 times a 3, which is a 9. Let's combine as many like terms as we can and evaluate some square roots that we can. Square root of 4 is 2, so this is going to turn into 16 times 2. We have 4 square roots of 6 plus 4 square roots of 6, so we should make that 8 square roots of 6. And we know the square root of 9 is 3. 16 times 2 is 32, plus 3 is 35, plus 8 square roots of 6. And again, if you have 8 square root of 6 plus 35 instead, that's completely fine. Last couple of problems on the warm-up. Number 6. We need to distribute negative 4 square root of 6 into the things on the inside of this parentheses. And then we need to add in what we have on the outside. So first, let's distribute. Negative 4 on the outside times 3 on the inside. Negative 12. Square root of 6 on the inside times square root of 2 on the inside. Square root of 12. Now we distribute the negative 4 square root of 6 with the negative 5 square root of 3. Negative 4 times negative 5 is positive 20. Within the radical, we have 6 times 3, which is 18. We still have this term on the outside that's going to be combined later, 5 square root of 48. We need to pull out all perfect squares that we can. So my little notes to self here is that I can find a 4 in there. A 2 squared lives inside that 12. 4 times 3 is 12. Another note I'm going to make to myself is that 3 squared, or 9, lives within that 18. And 9 times 2 is 18. The last note to self I'm going to make is that within 48, there's a 16. So a 4 squared lives in there, times 3. Now that I have that, I'm going to start making some combinations. Don't forget these terms are sitting out here. They need to be brought along for the ride. So negative 12 times the square root of 2 squared times 2. And then the trash left behind is the square root of 3. Plus, don't forget this 20 comes along for the ride. The square root of 3 squared is 3, so I bring that outside to be multiplied by the 20. And I leave behind the trash the square root of 2. Bring the 5 with it. The square root of 4 squared is 4. And I leave behind the square root of 3. I have negative 24 square roots of 3 plus 60 square roots of 2 plus 20 square roots of 3. Do I have any like terms to combine? Well, I can't combine square roots of 3 with square roots of 2, but I can combine square roots of 3 with square roots of 3. So since I have 20 of them and negative 24 of them, I have negative 4 square roots of 3 and the 60 square roots of 2. That's our final answer. Number 7 is interesting. There's definitely the long way, right? We need to fix the fact that we have a radical in the denominator of number 7. And typically, we use the fact that we can multiply the square root of 8 on the bottom to spit out an 8, which is a nice rationalized number. And then, of course, we do this on the top. You absolutely positively can do that. I've got a shorter way, though. If you've already done this one, check your answer and see if it goes along with the answer I get with my shorter way. The shorter way is, I look at the fact that 8 goes into both 40 and 24. So I think of this as 3 times the square root of 40 over the square root of 8 plus 2 times the square root of 24 over the square root of 8. Or 3 times the square root of 40 over 8 plus 2 times the square root of 24 over 8. Well, this is a lot more helpful. What's 40 divided by 8? Well, that's just 5. Square root of 5. Plus 2. What's 24 divided by 8? 3. So times the square root of 3. Can I split 5 out anymore? I cannot. Can I split 3 out anymore? I cannot. I'm finished. If you did this problem by multiplying the top by square root of 8 over square root of 8 to begin with, check and see if you match my answer. You should. Both methods will work.